All right, back for part two. Example two. Fur coat purchased for $8,000 was appraised at $5,000 8 years later. So it's gone down in price. Assume the value is exponential. What's the average rate of depreciation? All right, well, if I look back at my formulas here, I don't hear anything about doubling time or half-life. So probably I'm going to pick one of these basic ones, right? And since it's going down, the amount that it's worth is going down. Probably it's one of these decay questions where the a value is going to be a fraction or a decimal. So let's try and set this up. Solution. And however you do this, this could be 1 plus I. That's up to you. I'll leave that up to you. And I'm just going to list all my knowns and unknowns. What do I know? That it was purchased for $8,000. So at the start, it was $8,000. And it was appraised 8 years later for $5,000. So at the end, it was $5,000, and 8 years later, so that's the amount of time that's went by is 8 years, and so hopefully it's A that I want to find, because that's what's left over. So let's get at it. A, and this is exponent 8. I'd like to somehow get to the A, right? Isolate A. What's the first step? Get rid of the 8,000. Divide both sides by 8,000. I'm not going to write this as a decimal. I'm going to get rid of the zeros. At some point, I want to put. I know I'm going to use my calculator, but I want to be exact as possible until then, which is actually right now, isn't it? How do I get rid of an exponent of 8? Well, it's the 8th root, or 1/8 is the exponent, or the 8th root, right? Because that's the exponent that will kind of undo 8 over 1 is 1 over 8. And again, this is the same thing as the 8th root. However, you would rather think of that, put it into your calculator. You jam that into a calculator, and you should get 1 decimal, no, not 1 decimal, you get around 0.943. So what the heck does that mean? That means on a year-to-year basis, the fur coat is keeping 94.3% of its value. It's keeping 94%. So how much is it losing? So therefore, the coat loses 0.057 or 5.7% of its value. And again, think about it. If it stayed the same, it stayed constant, it would be 100%, which would be 1.00. But the amount is actually 0.943. It's decreasing. It's depreciating. And the folks that use this formula, by the way, can see, because it's a decrease, would have this 1 minus r equal to 0.943, and then solve for r, and you still get 5.7%. Dandy. Ooh, long question. One spot where exponential functions and logarithms come into play is this idea of carbon dating. And I don't know much about carbon dating or the process or whatever it means, but I know that it's used. And if you actually want to ask your chemistry teacher about this, what's the difference between C12, C13, C14? I don't know. Ask them. But I know that it's used. And so when an organism dies, the amount of non-radioactive carbon stays the same while the amount of C14 decays exponentially. And they use this idea of how much C14 is around to see how old bones are. So Ferd finds a bone, of course he does, in a cave and believes that it belongs to a dinosaur. He tests the bone and finds the bone contains 85% of the C14 compared to the non-radioactive carbons. By the way, this part, I don't know. That's chemistry. Hopefully you might know a little bit about this. But we'll see. The math is actually pretty nice. Um, Notice here, half-life. So we're going to use the half-life formula. And notice this is the H value. So if I write down the half-life formula, it's here. P over H, where M, C, T, and H. And I know the half-life is 5730, and like you've talked in chemistry probably, the half-life of some of these radioactive materials is really, really long. All right, what else have we got? Notice not a lot of more information. We don't know how much there was to begin with, right? We don't know. In fact, if I just call, I could call this 1 gram or 1 kilogram, I don't know, but I know whatever it is, it's going to decay to 85% of that, right? 85% of whatever it started, where actually it doesn't matter what it started at because I'm going to be able to cancel it on both sides, and you watch how that happens. Did Ferd actually find a dino bone? Well, that depends on how long this is. If this was, you know, millions of years, yeah, okay, maybe Ferd found a dinosaur bone, but if this isn't millions of years, then Ferd goofed, and guess whether it's the case that Ferd goofed or not. If you don't like this idea of the C, well, then you can pick any amount. It started with 100 grams and then would decay to 85 grams, whatever. I just know that whatever I started with, it's 85%. So watch how this works. On this side, it's 85% of what I started with, and I don't care what I started with, but the half-life is 5730. Okay? And this is just a known thing, given in the question in this case. Notice that at some point I'm going to want to get my unknown, t, out of the exponent, but how do I do that? I'm going to take the log of both sides eventually, but I got to get rid of the c. Notice when I divide both sides by c, it's gone, and that's why it doesn't matter what I start with, how much I start with. So what do I got? I got 0.85 equals a half, and if you don't like a half, you can write it as 0.5 like that. That's fine. And t over 5730, and then I want to take the log of both sides, right? Get the unknown out of the exponent, get it back down to ground floor. That's got to go back down to ground floor. And now it's just not routine, but getting to be routine, right? How do I want to get t alone? I'm going to cross multiply here, multiply by 5730, divide by this to get t alone. So it's kind of like this gets multiplied up here. And again, I'm writing it in exactly and then put everything into the calculator at one time. That's times 5730. Since this is multiplied here, it's divide on the other side. And now jam that into a calculator. That times that divided by that. You should get, it's a pretty old bone. 13,443. So the bone is old, but definitely not a dino bone. Okay, that's it. We got some for you to try, and then tomorrow, or next day, whenever that will be, we'll see how logarithms show up more so than in, these were all exponential type things. We use logarithms and solve them, but these were exponential formulas, right? Similar to grade 11. But we're going to see formulas with logs in them. So have fun with that homework. We're only a couple of days away from a test now, folks.